All right, so we're going to take functions and we're going to find a way to represent it by a power series. That's all we're going to do. One of the reasons that we do this is I don't remember if I already spoke about it in this class. A lot of people are asking me that they feel like this chapter is very pointless because you're getting these Taylor polynomials so that you can get approximations of things that you can already do on the calculator, right? So you said like earlier, a couple sections ago, I asked you what's sine of point 1 using a Taylor polynomial, and we use the error, etc., etc. And you're like, well, that's pointless. I can just use the calculator. My question is, how do you think the calculator does it?
Doesn't it do the plug in every single point?
What's that?
Doesn't it put in like every single number?
But how does it do it? The question is,
Like
we got a programmer, right? So it's got to be programmed somehow, some way. I'm going to be honest with you. Everything we're doing, the calculator is programmed to do it. So the way you're doing the problems by hand, the calculator has been programmed to do it for you. So when we were doing the whole sine of point 1 and we did it by hand, the calculator did all that. It has been programmed to do exactly what you did by hand. So a lot of times they ask me, well, what's the point of us learning it? Well, if somebody doesn't learn it, then we can create software that does it for us. So the calculator literally uses the idea of power series to find out transcendental functions, to find out like very difficult things that we can as easily figure out algebraically. So I just want to make sure that you understand that's the reason why we're covering. Okay? So let's just kind of go ahead and jump into an example. So let's do find a power series for the following. So we're going to give you a function, f of x equals to 4 over x plus 2, and I want you to find a power series that is centered at 0. Now, the whole idea of the center is important, right? Because that means that whatever we use here, it's only going to be good enough if we're close to 0, right? If we're somewhere else, then we got to change the center. Agreed? Okay. Here's what, when I look at this, it reminds me of. And hopefully it will also remind you of this. This part right here looks very, very similar to something we've already covered in this class. And you cover this in pre-calc. This right here is the sum of a geometric series. Do you guys remember covering that like earlier in the year, even in pre-calc? So literally, if it's a geometric series, doesn't that mean that we have something like this? This is a geometric series. And we know that to find the sum, we would say a is over 1 minus r. You guys recall that? Here's what we're going to do. Because this purple here is so similar to this, I'm going to find a way to make this purple look very similar to the green so that I can go backwards and write a series. That's what I'm going to do. Okay? Now, what's very important about this is I don't really care what A is, and I don't care what R is. Well, we care when we're going forward, right? R has to be less than 1, right? We've talked about that. You with me? But since we're going to go backwards, I don't really care at this moment what A and R is. What I do care is that I have a 1 minus R. 1 minus. Okay? I'm going to try to achieve that here on the purple. You ready? So what I'm going to do is I'll do this example with you guys, and then hopefully you can kind of replicate what I'm going to do. So are you okay if I rewrite it like this? Yes? So I know I need to make it look like 1 minus r. So what I'm going to do is I need to make this 2 into a 1 without changing everything. Like I can't just make this into a 1 because that changes the expression, right? So what I'm going to do is if I make a change to that, everything else changes. So I'm going to divide everything by 2. So if I do that, 4 divided by 2 is 2. 2 divided by 2 is 1. And then x divided by 2 is just x over 2. Question. Are these two expressions still the exact same thing? Yeah. They are. It's I don't know if simplified. I think this is simplified. I kind of did the opposite, right? I kind of brought more terms in here, but just so that I can get to what I'm trying to do here. Okay? Now, I almost got it the same. I have a 1, which is what I want, but I need a minus. Any thoughts of how I can do that? Good. This simple right here. What if I just do this? Like, is that the same thing? I'm going to be honest with you guys. You're not going to struggle with the concept of going to, like, you're going to understand that you need to go here. What I see my students often struggle with is the algebra to go from here to there. That's going to be what's going to make this challenge in the algebra component of this. Because look, we're here. Now that you're here, you are ready to write your power series. What's your A value? 2. What's your rate? To the n. That's it. That's it. Now, because I want to make sure that we're practicing things so that we don't forget it, isn't this a problem that I could have given you in last night's homework? Just like, without you coming up with it, like, just that. I could have given you that problem and asked you, what's the interval of convergence? Cool? Yeah. So now let's just add the extra step. You figured out the problem. Now tell me, what's the interval of convergence? How do I figure this out? Well, isn't this geometric? And in order for a geometric to converge, the rate has to be less than 1. So what in here represents the rate? Has to be less than 1, right? So what does that mean? X has to be less than 2. Where are we centered? We're centered at 0. So this is geometric. What's your interval of convergence? Negative 2 through 2. And you don't even have to test your endpoints because it's geometric. Your endpoints would make the value be 1, right? And we know that if it's 1, it diverges for a geometric. It has to be less than 1. You with me? Cool? We're going to do this for every problem to make sure that you practice this whole idea of the interval of convergence. By the way, what's the radius of convergence? 2. R equals 2, right? So, just practicing a little bit of everything. Do you guys get what we're doing here? Cool? We're just gonna, they're gonna get a little bit more harder as far as the algebra, but it's literally the same concept here, okay? What's up?
So like, I get what we're doing, I still just don't understand why.
The why?
What do you use this for?
This thing is full of series. The software for this,
Right.
everything it does for you is a series. So whoever programmed this, so in this case Texas Instruments, their engineers are very good at power series. And they figure out all the series that would help you figure out like sines and cosines and tangents and whatever. Because no one really, this is how, I mean, back in the day, if you wanted to know like what sine of 0.1 is, and this sounds stupid, but there were mathematicians that were paid to do this all by hand, and they would create charts.
No.
And you had a chart. Matter of fact, in statistics, isn't there a chart that you guys use with all the p-values and the z-scores and all this stuff? Well, something like that similar, but for just everything. You had a chart for like every single trig function, and that's what they were basically paid for. They would make these charts, and people would use them. If that's what if you needed to figure out the sine of 0.1, then you hope that you had one of those charts, or that you knew someone that had one of those charts, and then you would find it. We've come very far, right? Someone was able to put all that into one of these things. Cool? Even in your phones, like think about it. Some of your phones can do, like even simple calculators can do logarithms and whatnot. So, I don't know if that gives you a good answer of what you were looking for. Why you specifically are doing it? Because you're taking the class. But whether or not you're going to use it, I don't know, man, to be honest. Cool? Alright, one more. Find a power series. Okay. We want to find a power series, but now we want it centered at 1. Okay. You guys ready? Once again, this looks very similar to the idea of 1 minus r. A over 1 minus r. Can we make that happen? How? I would hope so.
Do we add a 1?
Like that, right?
Oh,
1 minus 1 plus x?
Yeah.
Is that the same thing as 1 over x? 1 over, I mean, I guess. Is it not clear enough that 1 minus 1 is 0? 0 plus x is x? Okay. Alright. Are you okay with what I did there? Like, all I did was just add and subtract the 1. That did not change anything. We need to make it look like this. How can I have it such that I have 1 minus and then a rate? What do you mean by that? So just put parentheses here? Is that the same thing as 1 over x? Because look, if you write it like that, what you're going to get is 1 over 1 minus x, right? Which this cancels out, but it leaves you with 1 over negative x. So you got to be careful. We do got to group things. So what if we group it with the negative in there and then factor out the negative?
What?
So if I factor out the negative, what would I be left with? 1 minus x. Now, is that the same thing as 1 over x?
Yes.
Like, you can try it, right? You with me? So then, what's your a?
1 minus, oh, 1.
What's your rate?
1 minus. It's also standard.
And guess what? You've already taken care of this being center of 1. It doesn't look like what you're used to. Because technically, aren't you used to seeing, let me kind of go back. This is on a side note. If you go back to Taylor polynomials, do you agree that you had some kind of derivative, right? So let's say n derivative at the c over n factorial times x minus c? You're used to seeing this as the center? Well, that's very similar. You can rewrite it. How can I rewrite it? This one is not really necessary. You with me? So can I write it as negative? Yes? Is that the same thing? Yes? Like, think about it. If I distribute the negative, right? And technically, I'm going to go even a step further. Could I do this? And we're done. Here's my series. And it's very clear. I'm going to be honest. I would have accepted this. But I just wanted to show you very clearly how the center is already 1. Like, all I did was just, I didn't really algebraic manipulate a lot. I just kind of thought about, like, well, can I break things apart still using rules of algebra? Yes, sir.
Will we always have both of those things covered? Like, how would we create this? Like, how would we make it get centered at a number?
How would we make it what, I'm sorry?
Like, if that doesn't happen automatically by us just doing the algebra, like, is there, like, are we going to come into problems where, like, after we do
No.
the algebra, we make it?
Not for what we're doing.
Okay.
Okay? Alright, are we good so far? Yes? Maybe? Okay, cool. Well, before we can get any more difficult examples, there's something else I need to cover with you. And I need to make sure that you can do operations. By operations, I mean like multiplication, addition, subtraction, things like that. Operations with power series. And it's very simple, but I want to make sure I share this with you. I want to make sure that you understand why I'm doing certain things. So I'll give you the certain rules, okay? First of all, let's say that you have f of x equals some infinite series of a sub n x to the n. Do you see how this is a power series? Now, I want to make sure you understand this series represents a function. That's what we're doing in this section anyways, right? You with me? But I'm going to give you another one. So g of x equals, and this time let's do b sub n. You with me? All I changed was this front part here. Cool? So, number one, here's what you can do. What if I ask you to do the following? F of kx, where k is just a constant, or a number. Cool? What do you think you can do?
I'll just split the k with the x and make sure that they're both under the
Literally, isn't this what it's telling you to input? Like, this is your input it into x. So I agree with Andrew. Literally, you're going to put this into x, but the entire thing has to be to the power of n. Cool? Alright, number 2. What if you have something like this? X to the, I don't know, let me pick a letter that we don't use a lot in series. What would be a good letter? What?
W.
Double W. Let's see. Okay, f of x to the w power. Cool? What do you think I can do? Same deal that you did with,
Okay, so we multiply the x.
but you need to remember from algebra that a power to a power is going to do what? So this is going to be x to the wn, right? Last one. What if you simply have something like this? F of x plus or minus g of x. What is it telling you to do? Add or subtract the two functions. Well, isn't it this what you have? So f of x, according to what you got up there, is represented by that. And then g of x is represented by, plus or minus, sorry, that. Agree? Well, we've got to be able to combine them to be just one series instead of two. Literally, just this plus that. I'm not even joking. Like, literally. Okay, but we can do one more thing. What do you notice? Do they have anything in common? You can add everything else and just kind of have it to the x to the n power, whatever it happens to be for them. And we're going to do an example with using this stuff, okay? But these are some operations. I think you already knew you could do operations with series. Just kind of want to make sure that you understand how it would go about. Cool? Why am I going over this? Let's see. You ready? The other two examples I want you to notice that we did were fairly simple, right? So you have a constant over the variable, right? And then the other one, you also had a constant, right? Wasn't it? Constant over some sort of variable. Well, what if I give you something like this? Okay, f of x equals 3x minus 1 over x squared minus 1, and we're going to be centered at 0. I don't know about you, but I'm very relieved every time I see a center at 0. Alright, it makes things easier. Agreed? Okay. I don't like the fact that I have variables here on the numerator. Because, remember, we're trying to make this into a over 1 minus r. And it doesn't seem that simple to do. Agree? Like, just look at that. Like, how am I going to get a 1 in the denominator? Let's start out with that. Like, I mean, I already have 1 there. But, like, this a has to be a constant, and I have variables. You with me? I can't just let that be that. Okay? Any thoughts? Yes, sir. What's up? What is that called? We're going to have to use partial fraction decomposition. Oh my god. Come on. You've done it a bunch of times. It's not that bad. Okay. Right? Do you see why I want to go in this direction? Look at the denominators of this. Doesn't this look similar to what we did in the first two examples? Do you understand why? Why we're going in this direction? Okay, so what would I do here to complete the square? I mean, not complete the square. Do the partial fraction decomp. Solve for a and b, so a times what? X minus 1 plus, and that would have to be equal to the numerator of what we're trying to decompose, right? Alright, what would be good x values to try? 1 and negative 1. So if I try 1, so if I plug in 1, this goes away. This goes to 2b, and this goes to 2. Therefore, b is equal to 1, right? If I try negative 1, I get negative 2a. That goes to 0, so plus 0 equals to negative 4. Therefore, a is equal to 2. Yes? Therefore, that means that f of x is equal to what? Now in our new decomposed. 2 over x plus 1 plus 1 over x minus 1. And now, I can look at each one of these individually and work with each one individually. Okay? Let's start out with the easy one. Well, really, they're not that difficult, either one. So which one do you want to work with first? The first one right here? So remember, we're trying to make this into a over 1 minus r. Cool? And technically, I have it right now as 2 over 1 plus x, right? There's one thing I can do really to just make that happen. I already have the 1. 2 minus negative x. Yes? So what would be the power series representation of this part of the function? From 0 to infinity of 2 negative x to the n. Alright, so we got half of what we need to do. Now we need to go to the other one. What can I do to rewrite it as 1 minus something? Take out a negative. So if I factor out a negative, would I be left with 1 minus x? Yes? And even better, can I throw this negative to the top? So what does this become as a power series? Of negative 1 times x, not 1 minus x, to the n. Do you understand why it's just x? Because this is your r, right? Right, remember how it's... Okay, now remember, don't forget that it was this plus this, so it's technically this plus this. Yes? Well, in order for me to add them, this term right here, I'm going to box it, has to be exactly the same as that one, which is not. Agreed? However, what can we do to make it be? Can I just pull out this negative 1 to the n power and then have x to the n? And then they're the exact same thing? Yes? No? Maybe? So then here's where we're at then. If I add them, I would be left with the summation from 0 to infinity of what? I can factor out the x to the n, and I'll be left with what? 2 negative 1 to the n, right? That's what I have left on that one, right? Plus, what do I have left on this one? Negative 1, right? Yes? You guys understand what I did? Like, they're both have in common this term, so I factor it out. Could I clean this up a little? Well, I wouldn't have a plus a minus 1, right? You'll just say minus 1, right? And, I mean, I don't see anything else we can do here, to be honest, okay? Is this center at 0? How do you know? Remember, it would have to be x minus something, which technically there is an x minus 0 there. So we've got our representation. This function right here, this series right here represents f of x, which is what we started with. This gets represented by that series. Cool? Alright. Let's keep trying more stuff. I am recording, yeah.
Smash that like button.
I'm actually deleting my channel at the end of the year.
What?
Yes. I discovered, let me pause this. Alright, here we go. So we got another example. We're going to do finite power series, but this time we're going to do f of x equals natural log of x. And we want this to be centered at 1. Okay? Alright, this looks completely different from the first 3 examples. Because remember, we were trying to compare this to the whole idea of having a over 1 minus r. This isn't even a fraction. You with me? Like, we're trying to make this look like this. It's not as simple as the first 3 examples. However, what did you say? However, I know that f prime of x, the derivative of this is 1 over x. And I know how to make that look like that. Matter of fact, we just did it for example number 2. Did we not do that for example number 2? What did we get as the answer for example number 2? Go back. Isn't this what we got, if I'm not mistaken? Yes? Or negative x, or x minus 1 with the negative in front. You guys remember that? Yes? Isn't that what we got? So, like, I want to make sure I don't lose you. Like, I'm pretending I did all that work and I got there, right? We already did an example number 2. You ready? Question, though. This series represents the derivative.
Integrate.
And to go from here to here, I have to do something called integration. So I need to integrate this. Yes. So it's really not as difficult as it seems. Just because there's a series symbol in there, it's okay. Everything you know about integration still holds true. Okay. So do you understand why I'm integrating? Yes. Okay. So here we go. We know that ln of x, that's what I'm trying to figure out, has to be equal to the integral of this series. You with me? Anytime you integrate, do not forget your dx. Alright? You're with me? Now, pause with me because I need to make sure that you understand. This is where I think my first period got really lost, and I want to make sure I don't lose you. When you integrate, don't you always have a plus c, which represents your constant of integration? What I'm going to do is I'm going to put it here so I can understand to you what happens to it. This plus c is not part of the integration. Okay, you're with me? Okay, you're with me, right? So I'm just showing you, like, after I integrated, that you get something and then a plus c, right? Well, do you remember how this is centered at 1? What's the natural log of 1? What would the c have to be then in order for me to be 0? You're going to have something here, and this has to give you some sort of result, right? It's going to be 0, because think about it. If you plug in 1, right, what do you get? 0, which gets you to, remember when we were talking about this, the series of 0, which is just 0. So the only way c would have to be 0. You're with me? 0 plus c would have to be 0. So during this process, the c is going to go away, and I want to make sure that you understand why it went away. Because of the center. You with me? Because of the center, I'm evaluating there, and that c is going to go away. Okay? Alright, so then let me kind of forget that. Let's actually integrate this thing. Cool? Alright. If I'm integrating with respect to x, that means that the n is just a number. Do you guys agree? How would you integrate this? How do you integrate? So, like, if you had something like this, if I literally just had something like that, what would you do? Because remember how I said n is just a number? Well, isn't that just a number? What do? Add 1 and divide by it. Right? What does this look like? Add 1 and divide by it. Do you guys understand what I did there? Because remember, this is just a number, the n. I'm literally adding 1. Cool? Are we done? Yeah, that's what we're trying to figure out. What ln of x, does this represent of ln of x? That's what we're trying to figure out. Does this power series, is that the same thing as ln of x? Yes, it is. So are we done? You're done. You found the power series that represents natural log of x. Last question. I said we're going to review this and I forgot. what's the interval of convergence of this thing? So the center is 1, right? So how am I going to figure out the interval? The ratio test? Okay, so if I do the ratio test, what's going to happen? The limit as n approaches infinity, the absolute value of 1 minus x, what's n plus 1 plus 1? N plus 2 over n plus 1 plus 1, n plus 2 times n plus 1, 1 minus x, n plus 1, right? The limit as n approaches infinity. Alright, this 1 minus x to the n goes away, right? To the n goes away, and then I'm left with this square and with this to the first. So this one goes away, and I'm just left with 1 minus x, right? Right? Because of the same powers. And in order for something to converge using the ratio test, I need to do what? This has to be less than 1. So what's your radius? Literally 1. What's your interval of convergence? If your center at 1? 0 to 2, because your center at 1, right? So if you go to the left 1, you get a 0. If you go to the right 1, you get a 2. Do me a favor, go ahead and test the endpoints. Mr. Karen. So we need to test the endpoints. So you literally got to plug those points back into here. Right? I mean, actually, right here, I'm sorry. This one right here. Yes? Okay, so I'm running out of space. I'm going to tear this page. So let's say if I try the 0. If I try the 0, I would have the following. The series from 0 to infinity, and if I plug a 0 in here, right? That would just be 1 to the n plus 1. 1 to any power is just 1, right? So can I just say of 1 over n plus 1? And this looks a lot like 9.1 through 9.6. Does this converge? Does this diverge? And by what test? Nth term test. So if I do the limit as n approaches infinity, it would be equal to 0, so it's inconclusive. Limit comparison, so what do you want to compare to? So we're going to compare to 1 over n, and we know this diverges by p series. And you want to use limit comparison, so you're going to take the limit as n approaches infinity of what? 1 over n over 1 over n plus 1, which is 1 over n, n plus 1 over n. I'm sorry, n plus 1 over 1, which is 1. And we know that it's positive and finite. Since this diverges, this diverges. So what point did we use for this? It was a 0, right? So if I go back to my page, the 0 is not going to be included, for sure. So the 0 is not included. Now I got to try the 2. So if I try the 2, I get the series from 0 to infinity. Alright, so 1 minus 2 is negative 1 to the n plus 1. Over n plus 1. Can I do the limit comparison test again? Because the limit as n approaches, I'm sorry, we don't need to, as n approaches infinity, and we're going to compare it to the same thing, 1 over n. Is that what we're comparing it to?
Would that work? I don't know if that would work.
No, it's not going to work actually. So can we use the alternating series? Actually, I cannot use the limit, thank you, because it's not positive, right? I have to use the alternating series test. So I'm going to take the limit as infinity of 1 over n plus 1, which is 0, which is the very first requirement. And then I have to show that 1 over n plus 1 is bigger than or equal to the next term, which would be, which is true. So what does that mean? Converges by what? Alternating series test. You see how everything's starting to connect? And the further we go into the chapter, the more and more work there is to it. So what is your actual interval of convergence if I go back to the from 0 to 2, including the 2, but not including the 0? Okay. Are you realizing how much work there is to this? As far as the AP exam goes, guys, think about it. There's not really a way that they can ask you all of this for a multiple choice question.
FRQ.
So a lot of these things may be FRQ, or a lot of these things may just be as simply as find the interval of convergence. And they're going to have a bunch of intervals, and then you got to compare them. Like I can assure you it'll have 0 to 2 with nothing included. 0 to 2 where the 2 is included and the 0 is not included. 0 to 2 where they're both included. Variations of that, and then one that doesn't make any sense. But as far as like every little step, as a multiple choice, is going to be difficult to ask you like as a multiple step problem. So they might just ask you what's the radius of convergence, and that's it. So the radius of convergence for this would be 1, right? Because from 0 to 2, half the distance would be 1. Things of that manner, right? Or it would just end up being in an FRQ. Cool? That pretty much brings us to an end. I mean, I have another one where we can practice the whole idea of integrating, but time-wise, I think we're kind of there. So you just got to practice this. You're going to run into, yes, you can integrate, and yes, you can take derivatives the exact same way that you did before. Cool? All right. Subscribe.